Today we're going to be adding and subtracting polynomials. Your standards are here. Also, your success criteria. To be successful today, you need to be able to classify polynomials. That means name polynomials. You need to be able to add and subtract polynomials. And you need to be able to model real-life situations using sums and differences of polynomials. You have several vocabulary terms to write in your notes today. So here they are. A monomial is a number, a variable, or a product of a number and one or more variables with whole number exponents. A polynomial is a monomial or a sum of monomials. The degree of a monomial is the sum of the exponents of the variables in the monomial. A binomial is a polynomial with two terms. A trinomial is a polynomial with three terms, and the degree of a polynomial is the greatest degree of its terms. A polynomial in one variable is in standard form when the exponents of the terms decrease from left to right. So standard form, your exponents will decrease from left to right. Your leading coefficient, so when you write a polynomial in standard form, the coefficient of the first term is the leading coefficient. A set of numbers is closed under an operation when the operation performed on any two numbers in the set results in a number that is also in the set. All right, so these are all very important. Some of these you may have seen before, and some of them may be new, but make sure these are in your notes. Pause the video if you need to, but make sure all of these are clearly written in your notes. Key ideas. This has several of the terms we just talked about here. Here's an example of a binomial, 5x plus 2. Here's an example of a trinomial, x squared plus 5x plus 2. Tri meaning 3. You can see there's 1, 2, 3 terms. The terms are separated by a plus or a minus sign. A binomial has two terms, and it is also separated by a plus or a minus. Your leading coefficient is your first coefficient in your first term. The degree is the highest exponent. If it's in standard form, you can see the exponents go 3, 2, 1, and there's not an exponent here, so this would be degree 3. And the number without a variable is called the constant term. So all of those are important words that you need to know. All right, example 1, finding the degree of each monomial. All right, so the degree is the highest exponent, or when it's a monomial, it's the sum of exponents. So this one has a degree of 2 because the exponent is a 2. All right, for B part, negative 1/2 x y to the third. All right, there's no exponent on the x, but it is assumed to be a 1. So you can assume there's a 1 exponent there. So the sum of 1 and 3 is 4. So the degree for this monomial is 4. C part, 8x cubed y cubed. 3 plus 3 is 6. So the degree is 6. D is a constant. It's just a number. So there's no exponent. There's no variable or exponent. So the degree is 0. All right, self-assessment. A monomial contains 4 variables. What is the least possible degree of the monomial? Explain. Take a moment, write that down, come back for the answer. All right, hopefully you paused the video, took a moment to look at this, but a monomial contains 4 variables. What is the least possible degree of each of the monomial? The answer would be 4. So each variable would have to have a degree of at least 1, and you would add those 4 together to get 4. Example 2, writing a polynomial in standard form. All right, it says write 15x minus x cubed plus 3 in standard form. Identify the degree and the leading coefficient of the polynomial. All right, so remember, by definition, standard form means you're going to put your highest degree first. So you're going to put your exponents in descending order. So if you look, 15x, that has an exponent of 1. X cubed has an exponent of 3. And then you have a constant term of 3. So your highest exponent or your greatest exponent would be 3. So you're going to put that term first, negative x cubed. And then you put your exponents in descending order. So negative x cubed plus 15x plus 3. So to write this in standard form, this is how it would look. This is considered a trinomial because it has 3 terms. The degree is 3 because that's the highest exponent. And the leading coefficient is a negative 1. So there's not a 1 there, but it's assumed to be a 1 because it just has a negative sign. So your degree is 3, and your leading coefficient is negative 1. All right, example 3, classifying polynomials. Write each polynomial in standard form, identify the degree, and classify each polynomial by the number of terms. All right, so A part, negative 3z to the 4th, that is a monomial. So that's going to be negative 3z to the 4th. There's no other way to write that. So that is in standard form. And your highest exponent is a 4, so your degree is 4. And it's one term, so it is a monomial. All right, B part says 4 plus 5x squared minus x. Put it in standard form. You put the highest exponent first, so 5x squared goes first. Minus x has an exponent of 1, and then 4 is your constant, so it goes at the end. All right, so this one has a degree of 2 because your highest exponent is a 2, and this one has 1, 2, 3 terms, so this one is a trinomial. All right, C part says 8q plus q to the 5th. So to put it in standard form, I need my largest exponent to go first. So it's going to be q to the 5th. And then plus 8q. That puts it in standard form. Then you can identify the degree. The degree comes from the exponent of the first term. So your degree is 5. That's the largest exponent. And this one has 2 terms, so this one is a binomial. All right, self-assessment. Write the polynomial in standard form. Identify the degree and leading coefficient of the polynomial. Then classify the polynomial by the number of terms. All right, pause the video. Take a few moments. Do A, B, and C. Come back to see how you did. All right, let's see how you did. All right, A part, 9z minus 4. That puts it in standard form. The degree is 1 because z would be assumed to have an exponent of 1. The leading coefficient is 9. And to classify it, it would be a binomial because there is 1, 2 terms. All right, B part, t cubed plus t squared minus 10t. Remember when you switch the order here, I forgot the sign, so make sure you get that sign there. That is a negative t cubed. This one doesn't have a sign, but because it's the leading one, it's assumed to be positive. So your degree would be 3. Your leading coefficient would be negative 1. And it has 1, 2, 3 terms, so this one is a trinomial. C part, x cubed plus 2.8x. The degree is 3 because that's your highest exponent. The leading coefficient is assumed to be a 1 because there's no number in front of your x cubed. And it has 2 terms, so this one is a binomial. Example 4, adding polynomials. All right, to add polynomials, you can only add like terms. That means if it has the same variable and the same exponent, you can add those terms together. The easiest way to do it is to group these to rewrite it as 2x cubed plus x cubed. Okay, so those are like terms. Those can be added together. And then do the same thing for each exponent. So then I'll do my x squares. That's my next largest exponent. So I'm going to have plus negative 5x squared plus 2x squared. And then I have plus x and minus 1. Those do not have like terms, so we'll just bring those down. All right, so we have 2x cubed plus 1x cubed. Assume that to be a 1. So 2 plus 1 is 3x cubed. And then I have negative 5 plus 2, so that would be negative 3x squared. And then plus x, and then minus 1. This would be written in standard form. So that's your two polynomials added together. This would be a third degree polynomial. And it has 1, 2, 3, 4 terms, so it would be a polynomial of 4 terms. Also, the first coefficient is a 3, so your leading coefficient is a 3. All right, let's look at B part. I'm going to draw a line down through here to keep these separated. All right, I have 3x squared plus x minus 6, and I want to add that to x squared plus 4x plus 10. I'm going to start with my x squareds. So I'm going to have 3x squared plus x squared. And then I'm going to have plus x plus 4x. And then I'm going to have minus 6 plus 10. All right, so again, I have 3x squared plus 1x squared. That's assumed to be a 1. 3 plus 1 is 4x squared. And then I have 1 plus 4. Again, put a 1 there if you need to. So 1 plus 4 is 5 x's. And then negative 6 plus 10 is plus 4. So this is in standard form. It has 3 terms, so it's a trinomial. It's a degree of 2 because that's your highest exponent. And the leading coefficient is a 4. Example 5, subtracting polynomials. All right, so subtracting polynomials is very much like adding polynomials. It's just one extra step. So the first thing is when you see 4n squared plus 5 minus, and you see parentheses, you know that that negative has to be distributed to each term inside that parentheses. So you can very quickly change this into addition. Let's go ahead and do that by distributing the negative 1. So if we do that, we're going to have 4n squared plus 5. And this just kind of ensures that you don't lose the negative. All right, so this negative here, take it to the first term, then you're going to take it to the next term, and the next term, and however many terms it is, because that's in parentheses again, that negative gets distributed to every term inside there. So you're subtracting every term inside there. So minus a negative 2n squared would be plus 2n squared. Minus 2n would be minus 2n. And minus negative 4 becomes plus 4. So if you do that as the first step, you kind of make sure that you don't lose those signs. You don't lose that negative sign. After this, you do the same thing as you did before. You just put the like terms together. So 4n squared plus 2n squared. And then I have a minus 2n. And then I have a 5 plus 4. All right, so 4n squared plus 2n squared is 6n squared. This one has nothing to combine with, so just bring it down, minus 2n. And 5 plus 4 is 9. So this one is a second degree trinomial, and it has a